Hi guys, we're going to go ahead and do our science for week 23. This week we get to make an egg protector. I am just loving all these science experiments. Today we are going to try to think like engineers. Engineers use science, math, and even art to solve problems. Our problem is to build a structure with enough ingenuity that you can insert a real egg into it and drop the whole unit without the egg breaking. But you will be given 50 of these little craft sticks, like the popsicle sticks. Should have them in your bags. Rubber bands, napkins, and a plastic egg to practice. For the real experiment though, I want you guys to all use a real egg. Before you start, let's think about the scientific method. The scientific method is question, research, hypothesis, experiment, analysis, and conclusion. So we're going to talk about building egg protectors today. So what's our question? How can I think like an engineer to build a structure that only 50 or fewer popsicle sticks, 12 or fewer napkins, and rubber bands would prevent my egg from breaking when I drop the whole unit from a very, very high place, like the top of a ladder or something like that. So you might need your mommies or daddies to help you drop it. Now, why would I care about building an egg protector? So egg protector projects help you explore the forces of gravity, force, and acceleration. The project combines problem-solving skills with the basic principles of engineering and physics. What an opportunity to apply what we've already learned. Here are some other reasons why you might care. The same principles are important when you invent and design airbags in your vehicle, helmets to protect your skull, brains, and eyes, NASA's Spacecraft Lander, which is a rover vehicle for landing on and exploring Mars, perhaps applying science and math to solve problems that will lead you to be able to help design the next space rover. Wouldn't that be really cool? What do you need to consider when you're engineering or designing your egg protectors? So let's think about that, okay? Have that in your mind while I'm finished reading all of this information. So we're going to do our research. There are two main questions to ask in our research. What do I need to consider when I'm building my egg protector? And what is the science of egg protectors? But to answer this last question, let's first think about what kind of work egg protectors have to do. For this egg protector project, the goal is to create a padded enclosure which goes around the egg so that when the egg is dropped from a very high height, it does not break. So some things you need to consider. You want to design that would reduce the amount of energy transferred from potential to kinetic on the eggshell. You've already have some clue about what we need to discuss here. So think energy, motion, gravity, force, mass, and acceleration. So all those concepts apply. So let's go over our facts about energy. What are two forms of energy? Two forms of energy are kinetic and potential. What is potential energy? It is stored energy. In an egg protector, the unit will have potential energy. And when you hold it up really high, when you drop the unit, potential energy turns into kinetic energy. When the unit hits the earth, the force of the impact will cause the acceleration of the unit to stop. You can calculate force by force equals mass times acceleration, which is Newton's second law. Newton's second law of motion states that force equals mass times acceleration. Newton's second law deals with the relationship between an object's mass, its acceleration, and the amount of force it exerts. Although weight doesn't impact the speed of gravity, its race to the ground, its mass does impact the force on the ground. The heavier an object is, the faster it is traveling, the more force it exerts. By reducing the amount of mass in the egg container, you're reducing the amount of force it exerts as it falls. Hope that makes sense. That brings us to Newton's other laws of motion. So you just had a reminder for the second law. So what are the other laws? Newton's first law of motion states that an object at rest tends to remain at rest unless an object in motion tends to continue moving in a straight line at constant speed unless an outside force acts upon it. This law means that the force acting on a fallen egg are equal. It will remain in its current state of motion. If a force greater than those acting on the egg is applied, it will accelerate. Acceleration means any change in velocity. Slowing down, speeding up, or changing in direction. If you hold an egg, the force you are applying are equal and unbalanced, canceling out the force of gravity. Therefore, it remains motionless in your hand. If you let go of the egg, gravity becomes an unbalanced force and causes the egg to fall to the ground. So, what an outside force acts upon the egg protector? It's the earth, but also gravity, air resistance, and any other obstacles that get in the way of the fall. So what's Newton's third law of motion? Newton's third law of motion states that there is an equal and opposite reaction. That means that when you exert a force on an object, the object exerts a force back on you. For example, if you were standing on a boat and pushed it off the dock, even though you were pushing the dock pushed back. That is what causes the boat to move away from the dock. This concept is useful in understanding why an egg breaks when it strikes the ground. The ground is returning the force from the egg and it meets the ground. What action is being done to the egg protector? The unit will crash into the ground, causing downward force. Equal and upward force will act on the unit. Using shock-absorbing material can help reduce the amount of force exchanged between the ground and the egg. In the catapult project, you were trying your best to build up stored potential energy using tension. Most good catapults convert tension and torsion energy that is more slowly and manually built up in the device before release. Now, in the egg protector, you're trying to transfer it. Egg protectors use the sudden transfer of energy from the force of the earth to the force of the unit. You're trying to transfer the impact onto the unit instead of the egg. You can't decrease the amount of energy acting on the unit, so you must transfer it. Can energy be created or destroyed? It's the first law of thermodynamics. It states that energy cannot be created or destroyed. You have to transfer that energy. We learned what tension during the bridge building contest. What is tension? Tension is pulling or stretching force acting outward. Would it help if you created a torque in your egg protector? We learned about torque when we did our experiment on week 16. The center of gravity is of the mass center. The object wants to spin. It would if you could get your unit to spin so it landed in the thickest part of the egg facing the greatest impact. Great egg protectors designers are energy transfer experts. The best egg protector designer is the one who can figure out how to transfer the most energy in the unit and not the egg, using the least materials possible, dropping the egg and its units safely from the highest height. So let's talk again about our materials. You will have your napkins, your popsicle sticks, your rubber bands, and your plastic egg. So hopefully everybody got your materials from Miss Katie. Here's your rubber bands. So at home, I want you to work together with your mommy and daddy or grandparents or whoever you have working with you, and you guys be a little team and come up with your design and think carefully about your design. You want to brainstorm it out first. You don't want to just get right to work. So our hypothesis is going to be, what's the best design for our egg protector using these supplies and why? What are the fewest amount of supplies you can use to effectively protect our egg? How high can you drop your egg protector without breaking your egg? Some things you might want to consider. Decrease the final speed of the egg using air resistance. Increase the time of collision using some sort of cushion. Transfer the energy into something else. How can you increase your unit's ability to deform without breaking upon its landing? Things you want. The padding to be soft enough so that it cushions the egg from the high impact forces during the landing. The padding to be thick enough so that it deforms during the entire duration of the impact. If it's too thin, it will reach its maximum deformation before the impact is over and the egg will break. Therefore, it must be as thick as possible. You can use up to 12 napkins, only 12 for this experiment, which are soft and could absorb the impact. If the egg breaks, you need to make the cushion material softer, thicker, or both. Each napkin adds more weight to your unit. To build a frame around the padded enclosure, also it flexes and deforms during impact landing. So it will absorb some of the impact energy and act as an additional buffer of protection between the impact forces and the egg. So here's a couple pictures that I have for you. See those okay? Those figures show a basic concept design for the egg protector enclosures plus surrounding frame. Based on what was talked about here, but these inventors forgot about padding. One of them used straws and tape and not popsicle sticks and rubber bands. So now you're going to go ahead and do your experiment. I want to see pictures, videos, whatever you guys can send me. You can post it on the Facebook page or send it to me via email. I want to see everybody's egg protectors, and I want to see them dropped, and I want to see if your egg held up. So go ahead and sketch away, sketch your design first, do all of your brainstorming, and then let's hear how you did with your experiment and what you would have done differently. Okay? All right, thanks guys. I can't wait to see your experiments.